Hello and welcome back to Anton Math. This is the first video of Part 5, Unit 4 of our pre-calculus series, More Trigonometric Graphs. And here in this first video, we're going to be focusing mostly on graphs of the two functions tangent and cotangent. Now, the first thing that we need to note about tangent and cotangent is that they differ from sine and cosine in that they have a different period. When we talked about sine and cosine, we figured out that sine and cosine both have a period of 2 pi, so they repeat themselves every 2 pi distance. But tangent and cotangent have a bit of a smaller period, right? The period of tangent and cotangent is actually just pi. So we have that tangent of x plus pi is equal to just tangent of x. And cotangent as well, cotangent of x plus pi is going to be equal to cotangent of x, right? They both start repeating themselves after a distance of just pi. So when we're graphing these, when we graph one period, we'll usually be looking at a smaller horizontal distance than when we work with sine, cosine, secant, and cosecant. Now I have the unit circle up here. I want to talk a little bit about why this is really quick. And let's just say I had some distance around the unit circle, t. And I know that at a distance of t, I'm going to have some point. This point's going to have some value for x, let's call it a, and some value for y, let's call it b. Okay. Now similarly, I can look at some distance around the unit circle, t plus pi, whatever this t is, just add pi to that t. So we're going to go all the way around. That's going to put us over in this third quadrant, isn't it? All right, so this blue line is t plus pi. And at t plus pi, I'm going to have another point. Let's call it q. Now, t and t plus pi both have the same reference number. So I know that the point P and Q are both going to have a and b, but whereas in quadrant 1, a and b are positive, in quadrant 3, I'm going to have a negative a and a negative b, aren't I? Back from our reference number section. So what does this mean? Well, in quadrant 1 here, we see that my tangent of t, this is going to be equal to my y value over my x value, right, by our definitions. So b over a. Whereas over here at q, I have tangent of t plus pi. That's going to be equal to my y value, which is negative b, over my x value, which is negative a. So I get a cancellation here in these negatives, don't I? And I end up getting b over a, which is exactly tangent of t from up here, right? So we have this smaller period where just tangent and cotangent repeat themselves every halfway around the unit circle. So we're going to need to take that into consideration in a second here. But I need to talk about one more thing first, and that one more thing is asymptotes. Some of you have probably heard asymptotes before. This should be a familiar word. But when we're graphing and we get to a point that's never reached by the graph, usually it looks something like 1 over 0, we get what's called an asymptote. And we want to find the asymptotes here for tangent. We'll work with tangent first. I know that here at pi over 2, I have the point x equals 0, y equals 1. And down here at negative pi over 2, I have the point x equals 0, y equals negative 1. Right? So from before we knew that tangent of pi over 2 equals 1 over 0. Right? We said it does not exist. Right? At pi over 2, tangent does not exist. But let's just say that instead of going all the way to pi over 2, I started here at my initial point, and I just got really, really close to pi over 2. Really, really, really close. Okay? All the way until, let's say my y, let's say I have this point right next to here. Let's say my y is getting really close to 1, so it's like 0.99, right? It's really, really close, almost to 1, and my x, is getting really small. And this isn't going to be exact. Let's say these are about, my y is about 0.99, my x is about 0.001, something like that. Well, my tangent at this point, let's call this t, is going to be about equal to 0.99 over 0.001. Now what happens when you divide by such a small value, right? If we divide by something so small, this is going to explode. This is going to be the same thing as multiplying this top by 100, isn't it? It's going to be 990. Well, let's just say I kept getting even closer. Let's just say that I got even closer than this. And I won't concern myself with what my y value is. I don't want to mislead you to think that that was accurate. Those were not really points on the unit circle. But let's say I get really close so that my x is getting even smaller. Let's say I get close enough so my x equals 0.0000001. Now, no matter what my y is about equal to 1. So y over this value is going to be about 100,000, right? And I can take x even smaller than this. I can take an x, let's add a couple more zeros in there, right? My tangent's going to keep getting bigger and bigger and bigger. All this to say that as I get closer and closer and closer to pi over 2, tangent gets bigger and bigger and bigger and never stops getting bigger. We say tangent goes to infinity, all right? But at pi over 2, tangent doesn't exist. So how do we show this on a graph? Over here, this is my pi over 2, right? How I show this on a graph is I draw this little vertical dotted line, and this is my asymptote. So what's happening is I know that at my initial point, when x is equal to 0 here, tangent's equal to y over x, or sorry, tangent, yeah, y over x. My y is 0, my t is 0. So my tangent's going to be 0 here. And as I get closer and closer to pi over 2, I'm increasing, right? I start increasing slowly at first, but as I get closer and closer and closer, I start dramatically increasing. And I just go up forever. I never cross this line. This is an asymptote. This line is uncrossable. As soon as I cross, if I cross the line, that means that tangent exists at pi over 2, but we know it doesn't. So tangent line never crosses it, but it infinitely increases forever as it gets closer and closer and closer to that line. Now the same thing's going to happen down here at negative pi over 2. As my t gets closer and closer and closer to negative pi over 2, we'll go over here to x and y, I have this other asymptote over here. And my tangent's going to keep getting smaller and smaller and smaller, right? I'm getting closer and closer and closer to negative 1 over 0. So it's a negative value, but that negative value is exploding just like it did when we were getting close to positive pi over 2. Okay? So this is my one period of tangent. All right? So this is my tangent, sorry, y equals tangent of x. This is my graph in blue over here. Okay, so this is one period, and we'll do some examples at the end of this unit with shifting, etc. Right now, I just want to show you this. Okay, now let's take a look at cotangent. Cotangent still has a period of pi. I kind of erased that, but cotangent of t plus pi is equal to cotangent of t, and I'll let you work out that on the unit circle yourself. It's for the exact same reason, right? Unit 1 to Unit 3 or Unit 2 to Unit 4. But cotangent has different asymptotes, right? Cotangent, we're concerned with when y is equal to 0, because cotangent over here, cotangent t is going to be equal to x over y. So y equals 0 is what causes some trouble. So that happens here at t equals 0 and at t equals pi, and any increment of pi, right? We know that from our domains video. So I'm going to be looking at one period from 0 to pi, and I have these points 1, 0, and negative 1, 0. So as t, let's say I'm looking from here, and as t gets closer and closer from this some point in the middle towards 0, right? My cotangent is getting bigger and bigger and bigger. It's positive again. My cotangent here is getting close to 1 over 0. So it's going to look something like this, right? I have this asymptote that's actually right on top of the y-axis. It'll be hard to see there. But again, at pi over 2 up here, this is the point 0, 1. So here my cotangent equals 0 over 1, or just 0. So that's going to be this point right here at pi over 2. And as I go to the left here towards x equals 0, my cotangent is exploding. It's getting bigger and bigger and bigger and bigger. Now my other asymptote is going to be over here at t equals pi. Right, so I'm going to go ahead and denote that by this little dotted line here. And as I get closer and closer and closer to pi, my y value here is getting smaller and smaller and smaller without bound. It just keeps going infinitely down. So this is about what one period of cotangent looks like. And actually, I'm going to draw that a little bit better. It doesn't start going down so quickly, right? Like this. Okay, so that's tangent and cotangent. Now before I go, I just want to make one little observation here. Let me bring my tangent back. We know that tangent and cotangent are reciprocals of each other. So they have a relationship. And kind of think of it, wherever tangent has an asymptote, that means it's 1 over 0. So if you flip 1 over 0, if you look at 1 over 0, that was 1 over 0. The reciprocal of this is just 0 over 1. So wherever tangent has an asymptote, cotangent is equal to 0. Wherever tangent is equal to 0, cotangent has an asymptote, right? Wherever tangent goes to infinity, cotangent is 0, and vice versa. If I were to continue my tangent graph, I only drew one period, but over here, so you can see the correspondence with cotangent, it comes up like this right here, and then goes like this again, okay? So we see all of the zeros and asymptotes line up for these because of the fact that they're reciprocals of each other. Okay, now in the next video, we'll be looking at how to graph secant and cosecant.